Did you know that the US news reported that the cost of medical malpractice in the US is $55.6 billion per year? Even the FBI estimated that the total cost of insurance fraud is $40 billion. These shocking numbers not only contributed to the high cost of healthcare, but the size of successful malpractice claims also contributes to high premiums for medical malpractice. Through this video, we will understand what should an organization do, what is likely to happen, why is this happening, what is happening in the business process. We will also look into recommended strategies and action based on test action strategies outcome, how to apply advanced analytics to make specific recommendation, and different advanced machine learning algorithm to understand the outcome impact. Do a root cause analysis, understand the effective visualization. So if you feel the need to dig deeper into medical malpractice and analytical perspective, sit tight as we bring to you all the information that you need right on your screens. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.
As a set agenda, I would rather like to follow a very simple and a crisp, let's say, table of content. I'm going to start by a small introduction, a couple of minutes, give you my background, the kind of activities that I've been involved in. Post that, I would get into directly on the setting up the context for what we're going to discuss today. So it's going to point out towards what are the key concepts, why we are doing what we're doing, what is the case all about, what is the problem at hand, and how the case is looking as far as the objectives and analysis performed is concerned. We then get into the details of what data is necessary, what was it, what we did, what were the characteristics, how we analyzed it, moving into the analysis section, wherein I'll give you a snapshot in the deck, but rather I'll take you live into the Jupyter notebook. As far as the terminology is concerned, I'll come back to that. But a notebook where we have actually done the scripting piece of the analysis to understand and dig in deeper into the data. Let's quickly get into why we have gathered today and what are the key concepts that we're going to be looking at when we try to target the session. Now, as we understand, the topic for the day is about medical malpractice and exploratory analytical perspective. So the fundamental question that comes across is, if we are looking at exploratory analytics, are we not looking at any other type of analytics? So to broadly put it into perspective, any analysis, doesn't matter what kind of a problem it is, doesn't matter what kind of industry we are dealing with, doesn't matter what complexity of the problem is, or what is the value that's going to be generated out of solution that we propose, it always begins with descriptive analysis. And people who are familiar with the background of statistics would know that it all begins with what's happening in the business. So we always tend to define the basics of what, how, where, when, which is like the 5W, instead of solving just the why question of it, because descriptive is just about describing as the process is, so as to understand what all pieces of information we need to dig in deeper. So that's the primary phase, which we call as the descriptive phase, wherein there are two classic type of distinctions that happen. Now, descriptive can be exploratory, which is when we are unsure of what we are looking for in the data. Something like what we're going to do today, which is the case of medical malpractice. When we don't know what data to study, we call it the class of descriptive statistics, or we call it the class of descriptive type of research under the research design setup. But if we are aware as to what we are looking for, the descriptive tends to move towards the diagnostic side, which is we know what kind of parameters, what kind of variables would have an impact on my target variable. I'll give you a very simple example. Uh, we all are familiar with the term called as customer churn. Now, when we say that customers are leaving or they are no longer participating or engaging with the organization, we call it customer churn. Now, there are several factors which determine customer churn. But when we specifically look at a problem for an e-commerce industry, we know that there are certain important variables that we kind of analyze to predict the possibility of a churn of a customer. So something like the demographic details of the customer, something like the last engagement duration of the customer with the organization, the number of times the engagement has happened, what is the transaction value, what has been the kind of uh, loyalty with the customer over a period of time, how long the customer has engaged with us. These become very critical parameters. And that's where we move a little away from exploratory to be a more descriptive in a form of diagnosing what are the variables that we have to study and why they are impacting. And that's a gradual progression from descriptive to a diagnostic kind of a scenario, wherein we try to analyze the root cause and we try to dig in deeper to uh, completely separate out all the other parameters which are not playing a role in predicting or in diagnosing the real problem. This is very similar to diagnosing in a real medical terminology itself. Now, we all get into the field of data science, machine learning, directly jumping onto the area of predictive analytics because we are all excited about the fact that we can predict something, we can forecast something for the future. Now, that's where we have to actually distinguish. And I would give a very flat percentage in terms of understanding that in my experience over the last 10 years and overall 15 years of experience with data, 70 to 72% of the problem gets solved by just describing it correctly. So the descriptive analytics, which is very, very basic analytics of the data, can solve 70% of my problem. Let's put it both the way. The remaining 10% is handled by diagnostics. Now, the the overall out of 100%, the 20% is something that has evolved over a period of time now with the introduction of huge amount of data, technology, the different kind of algorithms, the kind of models that have come up, the kind of open source availability. But still, the pie of predictive and prescriptive is still lower as compared to the descriptive and diagnostic. But that doesn't mean that the value is any lesser. So if you look at the graph, you will understand that as we go from descriptive to prescriptive, it's not just the increase in complexity that happens, it's also the increase in value that takes. So even if you're solving 10% of your problem using predictive and prescriptive, the amount of contribution that you make to business is humongous. That's why we kind of target towards achieving predictive and prescriptive capability. Wherein the idea is use historical data patterns to predict specific future outcomes. Now, it's not like a black box. It's not like a what you call it's not like some kind of a magic which takes place. It's a it's a very structured approach of uh, drilling in the data to go to the next level of prediction. Idea is, can we identify the right set of features and can we identify the right set of target variable that we have to consider when we are looking at doing any level of prediction. Finally, the prescriptive is the one which is about the recommendation. Now, this is where, even if you look at it from a perspective of a career, when you start your career, somebody who is as fresh to data science and machine learning as you are, or some of you must be experienced candidates now, you can fit yourself into each of these roles. So you start from descriptive, which is where most of the business analysis of the data analytics job, most of the data science starting from, you do a lot of this, you do a lot of dashboarding, you do a lot of business intelligence, you do a lot of data exploration, you do a lot of data processing, data crunching, data wrangling. All these terms you will hear will come under the fold of descriptive. From there, you go to the diagnostic. And as you move up the ladder in the organizations, you tend to go towards descriptive, which is about recommending strategies, recommending, let's say, steps to the organization as to what they should do based on the problem at hand, and helping them. It's like a hand-holding process of going along with them in the journey of prescribing as to what data they actually. And there are numerous examples as we go forward. We'll talk about that. Now, so today's question is about descriptive statistics. It's about the exploratory part of it. So what we do as a first step in data analytics is we do the descriptive part. How do we go about it? We summarize the data as much as possible. And when we say descriptive, these are four key pillars. Or what I call out of the pie, I have to give equal weightage to what we say as central tendencies and what we say as measures of central or measures of variation. Now, frequency is a simple grouping exercise where we kind of understand which variables, which of the parameters, which of my features are playing more important role. We give a count to them. And then from there, we go to averages, which is the central tendency. From averages, we tend to look at how individual observations kind of vary from the central tendency. And finally, where exactly is my data residing? So we look at what we call as quartiles, deciles, percentiles. We make use of both the central tendency and the variation side by side. And today in this session, I'm going to discuss about all these four, a lot more, but from a very different perspective of solving a problem. Now, naturally, the next question comes across is, why is it so important to do exploratory analysis? What is it about the organization? What is it about the problems? What is it about the situations or the processes that exploratory analysis becomes imperative for us? Now, there are certain typical challenges that organizations face. There is a complexity of multiple data sources. There is a complexity of lack of effective ways to understand the relevant data. There are multiple times their data does not connect so that they can kind of generate a complete picture of the processes. They come kind of lack the understanding about their customer behavior because they haven't put the right set of variable about the customer behavior across the right variables that they can analyze better. They don't know how the trend is changing. They don't know what is the complete 360 view of their customer or the processes dealt internally, which could be a manufacturing process, which could be an insurance service process, which could be a financial process. It could be as simple as a P2P process, where in the procure to payment process, we have to analyze each and every step from uh, the generating the PR, from getting the invoices, getting the contracts, generating final PO. So all the steps, we don't know how all these, let's say, stages can be put together using data. And on top of it, organizations do not know what metrics we should consider to just monitor the performance of these processes. They have no idea as to uh, what are the specific variable and their relationships that we should kind of generate specific metrics that would help me keep a track of the process. I'll give you a very, very simple example. Think about dashboards like in a car. Imagine you driving a car without an RPM indicator or without an odometer wherein we don't see the speed. Imagine it driving without the indication for your turning right and left. You would say we can always do that. There is no need to see the speed. We can always drive the considering, let's say, the lanes that we are in, or considering that what is the safer zone where I can personally draw in and drive within that. But the question comes across is, how would you standardize it? Now, there are so many other things that are happening in a car. Why a dashboard only talks about RPM and odometer? And let me give you a very interesting analogy here. Imagine driving a car without the fuel indication. Can you even think about imagining driving a car without a fuel indication? Now, parallel is the thing. You can compare it with driving a business without the monitoring of the performance of the business. Now, this is where visualization, this is where exploratory analysis, this is where descriptive analysis, this is where standardizing of your data to generate greater insights by defining those metrics plays absolutely the critical role. So in the last 10 years, what organizations have basically been able to find out is if we are unable to put the right metrics on top of our processes, we will never be able to improve them. That's why you see a sudden jump into the area of data analytics. Because now imagine any step in a business is connected to a process. So if you're analyzing any process, how would you do that? You would have to create the right metrics by exploring the data with which the process is connected with. And finally, define those metrics which can help you monitor those particular kind of processes better. Not only better, they can help you improve as well. So what do we do? What do we do when we talk about the exploratory analysis? We understand we have these typical challenges. We then start with standardizing the data so that everyone who's making use of the data in the organization has an access to called as a single source of truth. So that's why concepts of ERPs, the SAPs, the databases, all these evolved during the 90s because they were trying to structure the data. More importantly, it is now required if we are trying to build on top of that data an application layer of analytics. That's where we come in as the data science or the data analytics. Now, under data processing, we not only look at standardization and cleansing, we also look at identification of the missing information. We do transformation of our variables. We do some outlier analysis, which I'm going to show you today as well. Now, with these, we then define what we call as the KPIs or the key performance indicators. Now, these key performance indicators are nothing but the metrics that I was referring to. So the metrics are something like the dashboard of the car that I mentioned. So we want RPM, we want odometer, we want the fuel to be visualized there. We want to see the battery indicator. We want to see any kind of customized metric that we want to put in the car. All those kind of KPIs are then put in here. So something like I'll give you an example in terms of, let's say, inventory management so that everyone can relate to it. For an inventory management process, the KPIs perhaps could be we want to measure the inventory turnover ratio. We want to measure the my stock out time. I want to measure my lead time over a period of time. I want to measure the economic quantity that I've been ordering over a period of time. I want to measure the cost of holding a particular SKU over a period of time. So whatever data point that is readily available to me, we would try to generate metrics on top of that to see if the information is made available to me at the right time. Am I enabling my team members to take the decisions in time? That's the beauty of defining the right set of KPIs. And they are completely open. Means every different process that you think about, you can define newer and newer KPIs every time you analyze it. That's the idea about defining KPIs. And finally, the outcome is that you're able to enhance your monitoring, you're able to efficiently analyze the trend and pattern analysis, you are able to dig in deeper to slice and dice the data to come up with insights which were not readily available. And finally, you get a 360-degree overview of the entire decision making process. So that's the key why we chose the session to actually have exploratory analysis as the key component. We can talk about predictive descriptive diagnostic as well, but that's the idea. Now, moving on to the case study, because I would want to spend some time on the live working on the data as well, on the scripts. So I'll give you a context as far as this particular case study is concerned. Now, this case study, as the title suggests, is about medical malpractice. And if any of you is from an insurance sector, primarily from a medical insurance sector, would kind of be, I'm sure, be aware of such kind of malpractice being happening more because insurance still in countries like ours is very at an infant stage. Not of It's not a mandatory affair, but countries like US, UK, Europe, primarily most part of it, Canada, Australia, New Zealand. So the insurance is the prerequisite for you to get any kind of medical treatment. So that goes without saying. Now, with this kind of facility, I would say, comes malpractice. Now, if you just look at the left side of what are the some kind of analysis that has already been done historically, which is close to 2.4% of annual healthcare spending in US alone goes under medical malpractice. That's $55.6 billion in a year. Huge number. So we are talking about uh, close to a Reliance, let's say, turnover in a year, or the net worth, we call it in that way. We are talking about huge malpractice amount. Now, there are over 7,000 insurance companies, which receives close to about $1 trillion of insurance premium annually, and they are responsible for uh, they're responsible for paying out the right claimants, the right amount at the right time. So they have a very simple objective to be achieved. The idea is how to identify which of those claims are not as uh, they are claiming them to be. So, how many of those claims are actually fraudulent? That's the objective. That's the idea about the case that we are discussing today. Now, if you look at from the pain point perspective, when they go into the study to understand uh, uh, how are they basically being cheated, or what are the variety of situations where claimants actually start to make use of the system against the insurance companies. So these are certain pain points. So what happens is high variety of fraud patterns and relatively inadequate ratio known frauds in typical samples. So what happens? The insurance company, once they pay out the amount, they would study the patterns or the historical data. Now the fraud is such that it varies completely from each other. So every transaction or every claim that is processed in the system is very different from another because of the medical, let's say, emergencies in the real life. So to identify these frauds on such a complex variety of uh, medical severities or medical emergencies or medical scenarios, it's very difficult to kind of find a pattern. Now, if you are looking at from an analytics perspective, if there is no pattern, it becomes the biggest challenge. Secondly, there is a range of activities which are not considered proper that claimants create. So they would create a situation that isn't covered under insurance, something like a drink and driving or something like an illegal activity. So they would create a kind of a situation so as to claim the amount, which is practically not to be paid for. Now, the third challenge is obviously like a judicial system. They cannot interpret the actual context of the. They are only perceiving it based on the documentation, based on the report that has been submitted to them via the medical or via a legal channel. So both the scenarios may be corrupted. That's the idea. And finally, how to know the true impact of the. So claimant might be increasing the estimates of the loss. So they might be charging, they might be claiming for unrelated kind of diseases or problems to increase the kind of a medical. So how how to identify that? Now these are kind of challenges that the insurance companies across the globe face. So very recently, just to take a couple of seconds, we did a project with a Gurgaon-based company who have set up a machine learning solution specifically for medical malpractice claims. I will give you the name of the organization because it's quite a startup. It's called Perceptivity, and they are into the business of finding out these insurance claims using machine learning. Please go out and check as to how they are doing it. This case is very relevant to what this company is actually doing. Now, we, along with them, we actually did a proof of concept for a very large UAE-based insurance company. In fact, it's the largest UAE-based insurance company, and they could not believe that they can actually reduce their 10 million worth of insurance claim frauds to close to a 2 million, from a 10 million to a 2 million. Can you imagine the amount of value that the process can actually bring in? That's what the whole idea of doing such an analysis is. And mind you, The machine learning part of the tool comes very later. It's the basic part of the descriptive analysis that is happening in the tool as well. And once you review that, I think that will help you understand this context better. So what is the case asking us to do? The case is asking us very, very specific things. It wants us to develop a kind of a better understanding of the claims paid out. So we must dig in deeper for identifying what are the different kind of situations, what are the medical malpractice lawsuits that perhaps are happening that we are unable to identify. Now, how do we do it? It's completely up to us. Now, in our case, as we discussed today, I'm only sharing the exploratory data analytics part of it. There is no doubt that we can go on to the stage of diagnostic, inferential, which is the predictive and the prescriptive part of it. There is no denying that fact. But to keep the focus for today's session, we are taking up the descriptive and the graphical analysis. And finally, the objective is to come up with recommendations. What kind of changes we should bring in the claim settlement process? Now that's the layer of prescription that we brought in, directly moving from descriptive to prescriptive, because we can recommend strategies. So they will want to do further analysis before going ahead and applying those strategies. But yes, so that's the level that we would like to reach using the live streaming data. So live streaming data means you file a claim online as a customer of an insurance company. Company either rejects or accepts or partially rejects your claim. These are decisions which are taken in hours. Now, with this live, let's say, decision making, we can actually do a kind of a fraud based assessment as well. Is the overall objective of the case that we are discussing. Now, how do we go about it? This was the process or the approach that we kind of followed. We first of all start with identifying the relevant factors or the features. Collect the data, whatever will be the sample data that we kind of analyze on the basis of that. Understand it. This is where the description part comes in. Understanding means we look out for any kind of missing information. We look out for what sort of variables we are trying to analyze, how. We understand the type of variable. So simple business statistics kind of work that we do. We then jump on to the analysis part, which is the descriptive analysis, which is the graphical plot, which is the summarizing of the data, which is about center tendency, dispersions, positions, frequency, all that happens under the analysis section. And finally, we come up to the recommendation section. Now, I would have loved to discuss this in a way that there are other possibilities of the data point as well, because when the team sits to come up with different kind of variables, there is no dearth of the data that is made available to insurance companies by the claim or by the customer, because the entire demography, the entire details of the medical history, the entire details of the medical history transactions is made available to insurance companies before they actually set up their premiums to the customers. Our question was what parameters to make use of or what factors to make use of in order to do the kind of diagnostics or then the kind of analysis that we wanted to do to figure out what actually happens. Some of the listed variables in front of you, which is highlighted in green, can always be debated, right? These are not the parameters which are the only parameters to be analyzed. But the idea is these were the key parameters which could give us an indication of what different types of claims we are dealing with and how these claims are kind of connected to generate some patterns. So variable like an amount, which is like a very basic, how much is the claim amount or the payment that has been made in dollars? What is the level of severity of the disease? So we kind of converted that into a scale from 1 to 9, which is a very ordinal kind of scale. 1 meant, which is like a very, very simple, or let's say lower on the medical ground, which is an emotional trauma. And finally, on the highest side being the death as the 9. Age of the claimant in years. So we always look at age as a very important variable as far as historical patterns and any kind of classification to be done. Whether there was a representative in terms of a private attorney or not. And this becomes very critical because this is where the business understanding comes in. There are a lot of claims which are actually filed via a private attorney. So that is to be analyzed in the data. What is the marital status of the claimant? What specialty of the doctor that the customer dealt with? so the disease specialty kind of the physician. Then what type of insurance do they have? Do they have like a public? Do they have a private? Do they have any unknown kind of an insurance? Do they not have an insurance at all? What is the gender? Now we moved on to the level of analyzing it in a way that we can look at what are the types of these variables so that we can analyze them accordingly. Now, the idea is elaborate them as much as possible to get much more details out of the data. So I'll stop by sharing my deck here and rather move between the deck and my notebook to give you a kind of a snapshot about how it all looked like when we started to analyze the data. This is the data that we are dealing with. Yeah, so we have amount of each of the claims. So the row items represent the each claim amount or the each claim transaction, and then the column represents the variables under consideration. The idea is very, very simple: what to analyze, how to start to narrate a story to the top stakeholders to identify the kind of recommendation that we would suggest them checking for every new claim that comes in. So that's the objective that we have to keep in mind. Now, what I'm using currently is a Jupyter notebook. I'm hoping most of you are familiar with it, but if not, it's just a quick uh, what we call as a development environment for making use of multiple type of scripting languages. We can either use R, Python. You want to do Spark, Scala. You can even go on to the level of making use of any advanced programming languages now. Right now, I'm making use of Python, and the idea is how, in a very simplified manner, I can achieve the objective of the medical malpractice. Now, my objective for discussing the script is not the script itself, but the outcome of the script. So I would rather not dig in deeper into how am I doing it, but what is the outcome of it. Now, what we look at in the first log, these are nothing but my libraries. What are Python packages, which are readily available in Python to perform any kind of analytics. This is a very basic NumPy and Pandas to do the basic mathematical and statistic work versus creating the data frames, which is where the data processing actually takes. The rest of the all is for the descriptive analysis. Is for the kind of analysis that we want to do on the set of data. If we were using any machine learning or any advanced level of environment, we would have imported those kind of packages. Once we are done with importing the relevant libraries, let me run it parallelly so that we know there is no problem at the end. So it has been successfully run. That's why it moved here. We then go on to actually read our data. Now, the data that you see here is the data that I just quickly showed it. So I'm just reading it. I just don't want any kind of error to actually come up. So you see the star that is coming up. The process is still on. Would wait for it to show the data head. There you see. So a snapshot of the data is made available to us, which is nothing but you can see in regards to that we have opened the Excel in the backend of Jupyter Notebook. So this is what data frames are meant to do. So you see this PD, which is nothing but how we are making use of the Pandas library. So that's what the idea is. So this is exactly the way the data isn't available in the CSV format. We are kind of now uploading it in the Pandas environment or in the Python environment. As I mentioned, the first and the foremost, the very basic steps in after we read the data is to identify for any kind of missing value, any kind of not applicable value, any kind of values which might not fit into the data that we are looking at. So what the idea is, we have created the the data frame, and we want to see what percentage of columns have a not applicable or a missing value in it. So the command that you see here primarily talks about to look into the columns where the data columns stored and find out these columns for missing values. So we are denoting the is an A bracket for kind of identifying those places where we don't have a missing value. So although the result is already made available here, you can see that the percentage column in front of each of the column names is 0, which is nothing but saying it in simple words that none of those columns have a missing value. But in reality, in your data case, you might have to deal with the missing value. And there are several ways of imputing your data, which means how you can fill out those missing values. So there are, of course, in your program, you're going to learn about multiple things related to that. But as of now, the data that we were dealing with did not have that. So there comes the first analysis that we wanted to perform. So we went on to first of all describe, and more importantly, before describing on that, I would rather, as a discussion point, and also as a as a as an ideology or a step-by-step process that you can follow, how to begin with the first step, right? So you have imported the library, you have checked for missing values. How to start with analysis, right? So the fundamental way of analysis that we kind of follow starts with describing each critical column. So we do what is called as a univariate analysis. So we analyze each column one by one and try to see whether there is a story that is coming out of each of those variables. And once we have done the univariate analysis, we then go on bivariate and multivariate kind of analysis, which means once we have understood that amount, gender, severity, how they are behaving, we then try to put two variables together. So how is amount with respect to gender? How is amount with respect to severity? How is amount with respect to the speciality of the physician? All those kind of things. So what I'm starting with is we plot the amount as the figure, as the variable, and see what is the variation like. Now, we have made use of box plot. There are several ways to plot the data that you want. You can plot a histogram of the amount. You can think about in terms of what all statistical ways that you can apply on a continuous variable to put it on a graph. Be very particular about the theory that you're applying in the back end. We are dealing with a continuous variable. We can't just put a what you call a line graph to represent amount because we don't have what is called as an over of time, because that's the time period sense of analysis that we can do. But the idea is we were trying to find out outliers. We were trying to find out where is the maximum concentration of my data. Now, if you look at the graph, I'm assuming that we know how to read a box plot. But the idea is, if you look at the amount on the x-axis, it goes till about 8,000, 800,000 to about a million. So if I look at these spikes and if I look at the box, it's also called the box plot. The box basically represents what I call it as my first level of layer of my quartile. My one, this is my three, and within the line that you see this, the black line that you see in between the blue box is my median, which is the Q2. So what we only witness from here is my median is close to Q1. There is a big difference between Q2 to Q3, which means the median and the third quartile are quite a farther away. What does this mean? So the question starts to rise. What is it that is happening here? What are the kind of questions that you raise to analyze and dig in deeper is the job of a practitioner. So once you plot a graph, the job doesn't end here. You just don't have to pick this graph and paste it somewhere for somebody else to decide on. It's your job to dig in deeper from here and find out what do we need to do from here. Now, if the same thing I look at in terms of data, you see the dispersion of the data here. So majority of the data lies right at the beginning between, let's say, 200,000 to 400,000. This is some of the extreme value, what in other words is called as the outlier value. So what in the data we have been able to identify by this plot is not like symmetric curve around its mean, median, and mode, which is called a normal curve. It's very much skewed in its existence. The other way to plot my amount, which is by plotting the histogram. Now you see from here, the skewness is very distinctly visible, or what we call as the outliers in the data are very, very clearly visible, because most of my sample that I'm dealing with from the data lies in the range of 0 to 20,000, sorry, 0 to 200,000. The majority of my data falls below 200,000, and only few of the claims are coming to on the higher side. Now, it has started to create a picture in my mind that there are certain claims where the claim amounts are pretty huge. I need to dig in deeper into that. Now, that's the first question that comes into the mind of any person who's analyzing. So we park it aside. We now know that our data on the amount variable is very, very skewed, and we have to be very, very focused upon how we need to understand that skewness better. Now, post we have done the amount, we start to look at the other parameters as well. How is my age? Now, as far as the plot is concerned, you can see in front of you, it's very close to being symmetrical around the average value. Perhaps looks like 40, though you can summarize and calculate the average value separately as well. But right now, what we see as a description in front of us gives a clear indication that age is not something which is not symmetrically distributed, which in the case of our context simply means that people from all age groups largely are applying for a similar number of claims. So large number of claims are coming between people of the age 30 to 50, but otherwise the people who are below 30 and people who are above 50, the count or the number of claims that are coming in are very much similar in terms of their count. We then wanted to study whether the data is also symmetrical in terms of the severity of disease, or there are certain diseases or there are certain levels of severity diseases which are being claimed for more. Now, very interestingly here, if you just look at this, you see three. Now, if you recall, I mentioned about the severity level from 1 to 9. 1 being a very low level of severity, which is an emotional trauma. 9 means death. Now, from an emotional trauma to a death, 3 is still closer to a low level of severity. There are over 50 of or close to 50 number of claims which have been made for very low level of severity. It's about fewer numbers of claims are coming as we go up the level of severity. Interestingly, we would want to see whether this, as the severity is going up, is there a kind of a relation between this severity and the claim amounts which were also going up? Now, that's the kind of a thinking that I'm trying to pass it on today. Descriptive analysis is not just about plotting. Descriptive analysis is all about asking the right set of questions from the graphs, from the charts, from the matrix, from the variables that we are plotting. Similarly, we go next. We now want to look at how two of my variables would start to behave against other. I'm just trying to figure out if I've left any univariate before I move on to the bivariate. Yeah, so I'll just quickly move on to the bivariate variable now. So if you look at now, what I have done here in the box plot is I have plotted the box plots for both females and males. And I wanted to see how the spread is. So if you look at very categorically, I can see the box is pretty thinner for males, very broad for females. If I would have been able to ask you this question, I would have asked, what does this interpret? But in practicality, we must understand these are greater inferences for us. We know the spread between the amount claimed by males is not that widely spread, whereas in case of females, the amounts are widespread. So there is more skewness as far as if we look at it from a perspective of females is concerned, there is outliers in the cases of males. So if you see these black spots denotes the outliers. There are outliers more in case of males, but most of the amounts that they are claiming for, they lie very close to each other. So I'm just making this number, but maybe because of the numbers that are represented on the y-axis. So Q1 to Q3, which means 75% of their claims are for less than $100,000. Not even 100,000. In fact, much lesser, because 100,000 is, I would suggest, is here. So this is close to about a 50,000 or a $70,000. So where females have a 75% of the population claiming under $100,000, males are claiming 75% of the males are claiming less than $50,000, so maybe $60,000. That's the level of understanding that we derive when we compare the genders. So can we kind of create a hypothesis that are females or males, let's put it one way, are male claimants charging for higher amounts, something like this, or is it the female claimant which is charging for a higher amount? Now that's where we move from being descriptive to a diagnostic or a predictive stage. So that's the next level of analysis, and that's how we progressively move. Now, what if I want to see the gender amount along with the insurance? So if you look at the insurance categories, there are 5 of them: private, Medicare, unknown, no insurance, and workers' compensation. I want to, and the color coding is basically according to that. And this has been divided across males and females. Now, a very simple uproot of what we have done here is simply suggest that females largely have private and Medicare. But males, out of all the 5, have primarily the private. So look at amounts close to 200,000, and over and above that, they are making use of the private insurance, which basically means there is a possibility that there is some loophole that is being detected there. So this becomes even an interesting point, digging deeper into privately insured males data. There are chances you would find fraud. That's not a claim that we are making, that's a possibility. And that's how you kind of analyze using the descriptive analysis. That's what I'm trying to throw here is think about in terms of wherever you find an anomaly in a graph or a chart as a possibility of exploration further. Now, this exploration is endless. The questions you can ask from the data will never end. But what is it that we are trying to look for is we are trying to understand the data from all possible variables perspective. Now, the case has been trimmed accordingly for our discussions here, but there can be multiple number of variables. There can be large size of the data as well. Here we are only dealing with about 120 odd claim data points. So now what I've done here is, for reference purpose, plotted gender and amount for the 20 cases from the data. So if you look at how the amounts are being distributed, so if you look at it from a perspective of females, you would be able to see the numbers that are coming up, and for males you would see the amount that is coming up. Now, what does this female 426 500? These are on the basis of what you call as the higher amount of claims that have been charged for. Now, the bars here represent, looking at from the perspective of amount that has been. So don't just look at here, it's 1.6, it's the gap which is being represented by the number. So we see the dispersion in the claim amount for the top 20 females has around 426,500 also as the claim amount, 311,500 also as the claim amount. Now that's the kind of variety, and as low we can see as 177,498. But in case of males, we see the amount has not even gone above 48,500 for their top uh, claimants. So the highest that I can see is 48,500. So that clearly is giving me a picture that female claimants are asking for higher claim amounts. I haven't done any kind of further analysis, but it's giving me a clear picture from here. What else I can look at? I can also look at plotting this a little differently. Now that's a scatter plot. That's a little different way of plotting the same data. The idea is I see a big amount being claimed by female. So this is you see the color coding, which is as high as 102 as well, but this is somewhere in between, and a small dot and a small dot here. So you can see the dots for the male is hardly any visible. This is the 401 that we were talking about, the max that we can look at. It's the same thing. I mean, the representation here is clearer. That's another way of representing it. If there were more values, we would have seen a lot more bubbles. That's the idea. Let's start to look at insurance type. What is happening as far as the insurance type is? So we see, irrespective of the gender, it's the private insured people who are claiming for the highest, where the highest amount has been clubbed up. So this is total. So for each claimant, we are looking at the amount and we are adding it up based on out of the total, how much is being divided by private, Medicare, unknown, no insurance, and workers. So we see what might give us an indication there are lesser chances of being fraud here, but that doesn't mean that proves it. So to prove it, we do diagnostics. Here we are exploring it. We find out where to look for. We would never have known that certain gynae related problems are claiming for the highest number of claim amounts. You see that? Now, this is a clear cut indication from the gender when we were looking at the top 20 female claim amounts that it is very well connected to the physician which is coming from a gynae specialty. Is there a possibility that the gynae being represented here are the same, or they are coming from the same hospital, or they are coming from the similar kind of background of, let's say, the gynaes are connected to each other, something of that sort. So that kind of raises the concern. Then there is a family practice. You see that? Very clear cut indication wherever we see a family practice as a specialty, it should raise our eyebrows. There's a possibility there might be higher claim amounts than their actual. By far, we know that amount is skewed, gender is playing a key role, the speciality is playing a key role as far as some special physicians are concerned, as far as their specialty, and also severity at a lower level is there are more number of claims. At the higher level, the has been going lesser. There's a parallel representation of these bars where we are interested in looking at the amounts. But if we want to look at the percentage of these claims made via the specialty in terms of overall pie, we see the 4 categories or 5 categories coming out predominantly the ones, which is the gynae, the family practice, the neurology, the general surgery, and the dermatology. So what are we getting as a picture by each step? By adding one variable to the other, we are kind of understanding that there are certain patterns with which we have to look at the claims. If you look at from the insurance perspective, that's the percentage. So we see 63%, close to 63% is about private. There are unknown 22% as well. That's a very, very high number if we are thinking from a perspective of fraudulent claims. From a specialty type, we have from the gender, we also can look at amount based on the severity type. So if we look at severity type 7 and 8 as an amount total, they take the majority of the pie. very interestingly, which means that people with the severity level of 7 and 8 have claimed for the highest of the amount. Although the number of claimants in with the severity of 7 and 8 is low, but the amount that they have claimed is very high, which means that people who are claiming for higher severity, higher amounts are to be looked in very closely. Now, wanted to ensure that I do not deal with the continuous variable on age, so I kind of bend it into the 10 labels, which is 1 till 9. So my entire age group is now divided into 1 to 9 group. And then we plotted what we call as an amount based on age. So that's the amount based on age. So what we see here is people within the age group. So 5, so let me tell you the labels. This is from 0 to 10 years. 2 represents people up till 20, from 10 to 20. This is 20 to 30. So this is the age group which is between 40 to 50. Now, between 40 to 50 are the claims which are the maximum amounts. Means the total of the claims claimed by people in the age group between 40 and 50 is the highest, followed by people in the age group between 30 and 40. Gives us a kind of an indication. Yes, age also, when it comes for certain claims, has to be looked in very carefully. So people from 30 to 50, there are higher number of claims or higher amount of claims coming from here. That's the idea, or that's the picture we are generating using the age. And in percentage wise, we see this as close to about, if we put together, this is almost about a 70% of the population falls under the range of 30 to 50, and that's where they are claiming the highest amounts for. Now, I would have loved to go in deeper. I would have loved to talk about how age with amount with severity, how age with amount with gender, how age with amount with insurance type, how age with amount with speciality, when we know these variables are playing, can actually be analyzed. That's the next layer of analysis. I would have then loved to discuss about the hypothesis that we create. So is the hypothesis that insurance type unknown perhaps fall under the category of fraudulent claims? We can test that. Or unknown type private or unknown type insurance are generally being found with females because we see higher amounts are being coming from females. Those kind of hypothesis is our next way of diagnosing the problem, or what we call developing a theory, which kind of helps us create a storyline about what different parameters, when put together, will help me in identifying, or let's put it this way, help me in predicting finally that a claim that comes in into the system is a fraudulent or a non-fraudulent claim.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.